Well, there we have it. All right, thanks for everybody for coming. Good afternoon. I get to do the really exciting part. Everybody comes here to talk about requirements. It's a little joke. People don't usually get excited about user requirements, so I want to make sure it's clear that what I'm here to talk about is user requirements. You know, we hear a lot about, we have rocket scientists at the front of the room. I'm not one of those. But we talk about specifications and requirements for systems, and all these things are all critical. But what I'm going to talk about is user requirements. And so you can go to the next slide, please. And so we have an evolving capability that we're developing at USGS in the Land Remote Sensing program, where we're really trying to take seriously some guidance that we've gotten, and we're recognizing the need that we have to really develop an institutionalized way forward for how we deal with and understand and characterize user requirements to help drive our programs. So we've gotten that guidance. We got it in the FY12 budget. There was language that told us that we needed to do a better job understanding and commit some resources and dedicate ourselves to understanding the land imaging requirements, so the user requirements. And so we really initiated a pretty concerted effort to try to get that going. And so we looked around and to find some partners to do that with, and one of our primary partners is NOAA, and we're collaborating with their Technology Planning Integration for Observations Office, who has been working on user requirements for a little over 10 years. A great asset for us to partner with. Next slide, please. So again, what we're trying to do is institutionalize this characterization exploitation of all Earth observing requirements. So as Tim alluded to in his opening statements, this is not a Landsat requirements process or a Landsat assessment. It should serve as providing information and helping to inform decisions for our Landsat program, but we're looking at this from the context of the Land Remote Sensing program as a program that looks at all our Earth observation services and all the Earth observation needs of the community that we serve. And so that's more than Landsat. Landsat is our biggest portfolio component for certain by a significant percentage, but we are looking at this from a much broader perspective. So we're trying to understand that broad perspective, build on previous successful models. We're designing a unified requirements architecture, partnering with a number of people throughout the community. Our principal partner right now is with NOAA, but we're also working with many federal agencies through USGS. I'm a vice chair of USGS, and we're doing some assessments involved with through USGS, and we're developing a process that's generating a significant amount of synergy across the community. So, next slide, please. So, what are we trying to do? Why does the Land Remote Sensing program care, other than we were told to do this by Congress in our appropriations, which is significant? As we understand that we need to do this. We need to do this to help justify our program, justify our request for funding, justify the decisions that we make. We need to make them based on proper information, information that we can represent, that we've acquired from the people that we're serving. So documenting these requirements and evaluation to provide us a capability to evaluate the services that we're providing is something that we have a critical need for, and we're developing that capability through this project. So informing program direction is a principal outcome that we're hoping to achieve here. And of course, the one in red is the one that is the principal outcome that we're looking at, providing service to the community we're talking about today, to help to inform the Earth observing design and development. Now, this process is to help us do that in a number of factors, but certainly here in this case for Landsat. Also looking at design and delivery of services, and then validating and adjusting data and information offerings for a suite of some 150 plus products that we support the archive and dissemination of from our EORES data center. So, next, please. So some of the principles, I've already kind of talked about this, broadening our view, but we have a suite of products and services that we deliver from the Land Remote Sensing program. Again, one of the primary is the Landsat, but also all the rest of the products out of that we support from EORES. And so in order to look at that, we want to evaluate a very broad spectrum of requirements and solutions. And so in order for us to be able to do that, we've determined that we need, that it's a principal component of our approach is to do that, is to maintain our requirements and our solutions separately, and to acquire our requirements in a solution agnostic approach. So that when we collect these requirements, we're not collecting them specific to any particular intended solution. We're getting requirements from users. They have requirements for observations, and we record those and catalog those appropriately. And then we characterize our solutions modeled separately, and we can compare the two together to optimize the application of solutions to requirements for observations. So this allows us to be able to focus in on any particular solution set, like in this case Landsat, or we can look across a broad spectrum of potential solutions and look at optimization of delivery of services from that perspective. So it's platform and sensor inclusive. We catalog all of our potential solutions. This could be remote sensing systems, it could be products, it could be services. We're all cataloged, modeled as their own sets of entities. And again, space, air, land, sea, in situ, in space, it doesn't matter. Different sensors, it doesn't matter. We catalog all of those, collect our requirements separately, and then we're able to make comparisons across between the two. Next, please. So in order to do this, there's kind of two major components that we break this program or project up into. I kind of got these backwards, right to left, left to right, but there's a system development component and a requirements elicitation component. So we have to elicit, we have to go out and get the information from our users, and we have to have some place to put it, manage it, and exercise functions against it to do analysis. So there's really two kind of separate things that we're doing. So first I'll just talk a little bit about the requirements solicitation. That's why that one's in yellow. So this is a very highly structured process that we've developed that we think is kind of cool. You know, if you can think about anything with requirements as being cool. It's really a process that hasn't really been done before that we're aware of. We've been developing it in partnership with NOAA and with the Office of Science and Technology Policy and with a number of other organizations over the last couple of years. We've run a number of pilot projects, and so, you know, the goals of this solicitation is, if you're going to have good information, you have to collect it right. You have to ask the questions right. You have to collect enough information so that you can provide the capability, once you catalog that, to operate the proper functions against it to support your analyses. So next slide, please. So again, we're not starting from scratch. NOAA, the TPIO, they've been doing this since 2003, so coming up on 11 years. They've been going through an evolution, and we've kind of jumped onto their moving train, and we're participating as a primary partner with them to go to the next level, the next generation capabilities for doing this requirements analysis. And so, you know, they've had this stuff. I don't know if anybody would know what any of this is, but the NOSA, which is the NOAA Observing Systems Architecture. So they were doing this in this requirements and solutions separately for a long time. We're doing that in a more integrated fashion in this next generation, but it's a similar approach. So this process that we've been developing, again, maturing the processes that were already at NOAA and developing new components and processes in this joint development that we're doing with NOAA now, has provided the basis for the assessment structure that you may or may not have seen in the published report out of the Office of Science and Technology and Policy from the National Earth Observations Task Force. The strategy that was laid out there was based on this process that we're developing here. So it's had some, it's developing into a higher order of maturity, and we're pretty excited about the results that we're starting to be able to see are coming our way with it. So So we have this whole development. We've got a number of pilot projects that have run using this process to help mature it. We have other inputs that we're using associated with trying to inform this process here, because our requirements project that I'm talking about here today has not reached the level of maturity to provide a single source of information to support this analysis. So we're using a lot of other information from previous methodologies and knowledge as well. So things like the Landsat application study that was done in 2012, which you'll hear a little bit more about later. Many years of corporate knowledge, 40 plus years corporate knowledge, many specific requirements analyses that were done for platform-specific applications or sensor-specific applications or different technologies and approaches or applications. Lots and lots of independent analyses, and we have a lot of information from that. And so this is joint effort to build on all that information to try to provide some input to this process. Next slide, please. So this process is it's a very highly managed. We call it an expert elicitation process. It's a pretty involved set of interviewing process. It's a series of stepwise engagements with the users. Iterative is not one time sit down. It's not a survey monkey. It's not a fill out this list. It's a sit down and interview and develop a customized elicitation for the business that the people you're eliciting the information are engaged in. So it's customer focused and customized discussions. I cannot produce a list of questions that I'm going to go ask the next client that we're going to elicit information from. It's custom developed on the fly. Some key elements is value tree, something that I'm going to go into here in a minute. This is a basis for developing traceability into to be able to associate the requirements that we gather to the business processes that they support. Expert elicitation is really the overall process of how we interview. Multi-attribute utility theory is how we apply the information in some of the modeling aspects. And then swing weighting is a part of the process where we've developed this methodology when we acquire this information to evaluate the impact or the contributions that the different types of requirements make associated with supporting the business. So we get some level of it. You could look at it as levels of importance of the different requirements that we gather. Next slide. So this is this value tree concept that we're talking about, and this is the basic construct that we're building our requirements under. It's kind of a little bit busy, but if you go look from the top to the bottom, it's really fairly straightforward. It's the top part there is this one here is a custom value tree that we would develop specific to the business model of the customer that we were addressing. So we would have one that was custom made for the Department of Interior, the Bureau of Reclamation. And we'd have a different one. We would follow their strategic components in planning. Their objectives would be mapped into this value tree at the top. So that's like the business part of it. And then you get into the middle, you get into these mission service areas, a grouping of activities for products or services. Essentially what we're doing is we're starting from the top and we're doing a business analysis and we're doing a decomposition process to build detail as we go down through the line of business that our customer is in until we get all the way down to the bottom where we start developing the detailed information associated with the Earth observing assets that these customers are using to support their business needs. Next slide. So some of the previous art and this previous work that's been done in this for some of the national analyses that have been done to date have done this under this structure that we borrowed from GEO, which is the societal benefit areas structure that we borrowed and modified to do some national level analyses for Earth observing systems in general. What we have is we've built this custom side on the custom capability on the left side to do specific business analysis and then also compare it with which would be specific to an agency or a department. And then we also can compare those directly with the societal benefits that those are contributing through. Where these value trees come together is through the key products and services areas in the middle of the value tree. And so what we can do is we can provide this traceability of the value and the contributions that the requirements and the products and services are making to a specific business need or to a societal benefit. So it provides us with a tremendous level of flexibility in how we can present the effects of changes in the bottom of the tree, where they affect the business or the values in the tops of the tree. Next. So that was kind of, the elicitation component. That's how we go about structuring how we're collecting and tracing the information and requirements that we collect. And of course, something that, we've done a lot of stuff like that, kind of like that in the past, but we've always done it specific to a solution. Like we'll go out and go, let me get your Landsat requirements, or let me get your LiDAR requirements, or let me get, and so what we're doing here is we're doing it in this agnostic approach. We're getting your requirements. Another thing that we're doing here, which I'll address here, is that we haven't done is we're developing a well-defined system to hold and manage all this information, so that you know, conceptually, once we ask for it once, we're not going to have to come back and ask for it again, because I won't have to ask you for your requirements for LiDAR and then come back and ask you for Landsat, and then come back and ask you for imagery, and then come back and ask you for that. We're going to get your requirements. We'll be able to apply whatever solution sets we want. So system development, next slide please. This is joint architecture that we're specifically developing this in a partnership with NOAA. We're doing, this is a software development, it's agile development that we're doing. We have developers both at USGS and at NOAA jointly working on this. So we're calling this EORES, great name. Somebody made that up. I think that was me. It's not good. So Earth observation requirements evaluation system. So you know, that's where we get the requirements, we catalog them, keep them in this system, and then we develop tools to be able to operate and functions against it. So ingest, validate, store, prioritize. You all know what an information system does, right? So it provides this architecture to store and manage information. Now, one of the you know, things that we need to keep on remembering about this architecture is for all Earth observations, right? So it's like, so the way we've designed this, and we did a pretty well thought out method of doing a conceptual design. We didn't just start writing code for a database. We had some architects come in and really look at what we were doing here and spend some time, about 8 months, doing upfront design work. So we're looking at all Earth observing assets. So we're looking through USGS, we're looking at CEOS, we're looking at all satellites, we're looking at all observing systems that we can find. So we've developed this system in a way that we can provide access to all these systems. We're not just looking at what USGS has, looking at what everybody has. We will be focusing on, USGS will be focusing on how we can manage our portfolio and help people understand when we don't have something in our portfolio to help them. Maybe we can point them to somewhere else where they can go and help be an information provider. But this system holds all information. So we're focusing on land. NOAA's looking primarily at atmospheres and oceans, and we're hoping that we're going to have NASA's going to be participating in some of this with the through the geo activities, and we're looking at some dedicated research for research systems to be addressed, and we're really looking at a very broad look at this system. So we're using the NASA GCMD as the base taxonomy for this system, so we have a language that we can speak that everybody can understand, and we can compare apples to apples and oranges across this enterprise. Next slide. Okay. So the project elements, you know, I was saying we did this conceptual and logical design. This was really well thought out. Database development, working as a joint development, and developing this standardized and enduring process. So it's a very highly structured process. Once we go out and acquire, it's going to be a long, kind of heavy lift to go out and acquire all these requirements. But as our sample size starts to grow, we'll start being able to develop some good analyses. And the really good thing is that this information should have a very, very long shelf life. You know, people's requirements, the things that people have to do, really don't change that much. They're relatively stable. So if you do a good job characterizing the requirements, then the solutions change, but the requirements don't change nearly as much. Next, please. So this is just because it's an obligatory messy slide that you have to put up for showing systems development. But really when I put this up here is to show that this is an early conceptual data model that we developed. I just put this up to show that the business, the requirements, and the capabilities, which is the capabilities of solutions, are modeled separately in the conceptual design. So we're really trying to stick to this approach of keeping these things separate, which is what gives them their long shelf life and durability. Next. Ongoing activities, future state. So this is an image. We have not completed the development. We're in development of the system. It won't reach initial operating capabilities really until next summer. So these are the things that are good, that are in ongoing development. We'll go ahead. Don't need to spend. Next slide, please. So a pilot project, so you know what I'm saying, we don't have a mature capability, we haven't really gone out and exercised this process. However, we did do a pilot project, and there's been a number of pilot projects that we and our partners in this have been executing. So we did one for this summer, and for moderate resolution, try to help to contribute to this activity. The purpose was, one was to help us mature our process and exercise our process and continue supporting the development of this capability, and the other was to provide an early look or a representative sample of some requirements to support this activity, to help inform the development of this architecture. So provide this representative sample. Next, please. So, representative sample, what does that mean? Well, it's we were trying to develop, elicit information that would provide us with a look at a representative sample of applications and requirements associated with applications of moderate resolution imagery. So we know what moderate resolution is talking about, 5 to 120 meter, Landsat-like. We actually had a suite of satellites that were associated with that particular ModRes set. So we looked at internal and external to DOI, broad topical coverage. So let's go to the next slide. We'll look at the representative say we didn't have enough time or enough resource to talk to 10,000 people to make sure that we got a representative sample of our user community. I don't even know for sure what that would mean. But we did try to get a representative sample of what we think is the big application sets for Landsat. And this, if you took this set of areas and compared that to like the slide that Tim showed with the big pie chart, I think you would see a pretty good agreement that these are some of the big, not all inclusive, but a representative sample of the application areas that are very popular for this type of data. So those are the ones that we acquired information in our pilot. Next. So what we tried to do in this pilot was exercise the development of our value trees to provide us the traceability of the information that we collected, and we tried to drive down into the bottom of that value tree to get some actual user requirements, the more detailed information in the bottom. And relatively quick, it was a couple of months talking to a whole lot of people, really, just kind of exercising the process. Next slide. So we did get some information back from that, and we had some previous analyses to compare our information that we acquired. And so this is a sample result. This isn't, you know, this is a very small sample size, but what this chart here shows is as a result of that elicitation, it shows the cumulative impact of the spectral bands from moderate resolution. So these are spectral bands from Landsat, Landsat 7. And what this shows, and you know, you've got those are the application areas on the right. Each of the colors represents the application areas that we acquired information associated with in our elicitation. And so what the impact means is the impact to the user's ability to do their business, to do what it is they're doing, to complete their work, do their application. And this shows the impact of the loss of that particular component from Landsat. So you look at the middle one is the near infrared. That's obviously the biggest one, right? And so each of those colors, you know, the orange is climate and land use. That's a representative. The orange band is representative of a relative impact of the loss of that capability off the bird. So this curve is a curve that we've seen before. So we think it's you know, some good information that's representative of some of the, it's not really value, okay, but it's representative of the impact that each of those components of this sensor on Landsat 7 are delivering to the users that are in these different practice areas. Next slide. Another way to look at it is, this slide is really, you know, the pie chart doesn't really tell you all that much, but this is really to tell you that we're dividing up our requirements into three different types of requirements. We got looking at them as requirements at threshold levels, breakthrough levels, and target levels to help. This is to help us to be able to do analyses of importance of in our multi-attribute analyses. So when we get threshold level, that means that this is the minimum specification below which this information is no longer really useful to the user. So that's a very important point in the curve. Then we got a breakthrough level, which is really like the knee in the curve, whereas at this level, it's where you would see a really significant increase in the level of usefulness of a characteristic of a sensor or a system or a product. And then the target level, which is the specification beyond which it's really not worth making much more investment because it's as good as they need to do their applications. Right? Next slide. Some more slices of the information to just look at some of these preliminary results. So this is just looking at some of the, just some preliminary looks at what's important, right? What some of the important breakpoints are when we take those 3 levels of application, of requirements to break through in the threshold and look at them. It's like, you know, so you see on the left one for horizontal resolution, you know, that 30 meters is a pretty big breakpoint for a significant percentage of the requirements that we gathered across these application areas. And look at the revisit frequency, similar type of thing. So this is just to show a couple of examples of analyses that can be performed. These aren't particularly informative charts in and of themselves, but just to give you kind of a look at it. Next slide. So as I said, the full capability of this NLI requirements is not available because it has not reached maturity. It's still in development. However, we do have data that we collected in this pilot project, which we're making available to the AST. We can perform analysis using that. We can fill in a lot of information and supplement with all this. We've been doing requirements for a long time. We've just been doing them in a different way. Been doing them perhaps a less structured way. Sometimes very structured, but specific to a cause. So we've been doing requirements a lot of different ways. We have 40 years of program engagement. I put that up there to just remind everybody that, you know, we have been working with this user community for a long time. Something that I think Tim mentioned in his opening is that we think we do know this community. I think it's important to document and provide traceability to the knowledge. And by the way, what we're finding is so far not been a lot of surprises to us, which is kind of validating to us that we actually do know the community pretty well. So we have numerous studies that were targeted to different products, projects, sensors, things like, and then of course we've got this 2012 application study that we did in support of the USGS NASA assessment of alternatives in associated with the 2012 RFI that we did. And that's what we're gonna, next slide please, that's what we're gonna really, what a lot of the discussion is kind of based around, or some of the framework for the approach of that John Dwyer is going to be talking about with the panel session, and how we're looking at recording information, additional information for supplement, in a similar way to what we did with this application study. So when we did the application study, we were looking at, well, what are all the applications that use Landsat, and then start, you know, taking away and adding sensor components and seeing which ones are affected. Similar kind of thing to what I've been talking about. And so what we did last year was we were developing this process that I've just been talking to you all about last year when we did that in 2012. It was much less mature than it is now, but it was there nonetheless. And so it was nice we were able to at least try to relate that to this value tree structure that I was discussing with you all earlier. And so that has occurred. And so the work that we'll do to collect stuff outside of this NLI process that's not yet mature enough to use fully here will be comparable. So next slide, please. So what you're going to see is you're going to see, these are some tables that you're going to see in John's presentation, so I'm not going to dwell on them, but that show this like sensitivity studies that are associated with specific applications. Next slide. That's just 2 of them. There's 4 of them here. John will have those. So that's what this panel session is going to do. It's going to use it's an application-based approach to discussing the observational requirements, and then discuss how those relate to the system-specific parameters that the architecture team is so concerned in developing. So that's what I had to say. Thanks for sitting through all that. I know that's a lot of stuff to look at, a lot of slides, but we're pretty excited about it. So we're going to switch now, and John Dwyer is going to come up, and our panel members come up to the table. Thank you very much.
I'll just ask in the next couple of minutes as we turn over the table, do you have any questions for us? You guys can come on up and get seated.
Hey, John. You repeatedly stated how you're looking at this study as a very broad brush. And I'm trying to understand how it's going to be used or narrowed down to the current issue relative to reliability, continuity, so forth, relative to the land imaging and budget. So to me, you used the word once value. Is there going to be some kind of input on value of some of the products and or bands, I'll say? And also, typically, the SWIR bands are all tied together as one. And I think we know that that's technically not equivalent, you know, they're all different. Are you going to address what the various SWIR bands do, just like you do with the other bands?
Well, first, can you hear me? Yeah. First, let me say I didn't mean to say any of that was value. Well, we're doing some level of valuation, but value usually infers that you have cost profiles, and my system does not have dollars in it, so it can't really be value. It's valuation, it's really, it's impact. Okay, so it's contribution to achievement of what you're trying to do. So it doesn't have cost, so it's, so I try not to represent it as value because it doesn't have that. Okay, so level of contribution, impact of loss. Really, impact of loss is what we're measuring. This is the quantification that we're providing, is impact of loss. And you can conversely say this is representative of a valued contribution, but not value in dollars. I don't have that information.
No, I understand that. That's tough. I understand it's left up to the architecture team and industry to
Right, so
figure
there
out
are
how to
other
use
factors that contribute
But I
to that.
understand value from a standpoint of usefulness to the users.
Right, and that's what I'm trying
Is
to.
that what's going to come out?
That is what I'm trying to represent, yes. And so cost will be added onto that. That's not part of the user requirement process. It could be. The system that we've designed actually is capable of carrying and maintaining cost. One of the things that's difficult for us, and particularly in the context that I'm presenting this in, of looking at not just in the USGS land remote sensing or USGS overall portfolio of assets, but the entirety of the Earth observing assets, is it would be very difficult for us to go and attain costs associated with that type of a portfolio.
No, I understand that, but it's what
So-
I'm trying to figure is how we could use this good data you'll be coming up with relative to what's been kind of like pulled together, saying can't cost more than this. It's got to have continuity. It's got to have reliability. You know, the tenets we talked about before.
Right. So we can do analysis. We'll be able to do analyses that show us the effects of those types of changes, which is really valuable towards being able to contribute to those decision points. So,
Right.
continuity. Well, what's that described as? It's described as, you know, being able to support these levels of observation. So I can tell you what the losses to the continuity are by taking components away. I can tell you which applications fall, or which customers are impacted the most, or what service areas are impacted the most. So we can show those, we'll be able to show those types of analyses. And then you'll have to apply cost to that.